Hi students, welcome to DOPA classes. Today I am going to discuss some important thing in the chapter dual nature of radiation. All of you know that in the chapter dual nature of radiation, the majority part is theory, and very lowest part is problematic. Okay, so we have to study the de Broglie wavelength equation very well. If you study the de Broglie wavelength equations, then it's enough for you for doing problem. Okay, so let me explain the de Broglie wavelength equation. De Broglie wavelength equation. Okay, so here the de Broglie wavelength equation, lambda, that is equal to h by p, and that is equal to h by mv. Ready? Clear? That is equal to another equation in term of kinetic energy, that is root of h by root of 2 mk. Then another equation of de Broglie wavelength in term of temperature, that is equal to h by root of 3 mkBT. That is equal to another relation of de Broglie wavelength with respect to electrovolt or voltage, that is h by root of 2 MeV, and that is equal to 12.27 by root V angstrom. Okay, so this is a set of equation. This is a set of equation for de Broglie wavelength. Okay, so here I am explaining the de Broglie wavelength equation in terms of momentum, and also in velocity, also in kinetic energy, and in term of temperature, in term of voltage, and finally 12.27 by root V angstrom. Okay, so this is the short trick to find the de Broglie wavelength. Ready? Yes. Thank you.
Hi all, you are watching a DOPA capsule class now. To know more about DOPA and DOPA capsule, download DOPA app and contact us using this number.